Hello class, and welcome to today's algebra lesson, which is about factoring quadratics ax squared plus bx plus c. By the end of today's lesson, you'll be able to factor trinomials with a leading coefficient, once again using our box method. So, when we were talking about our trinomials in our last lesson, our a value, or our first number in our trinomial, was always 1. So all we had to do was look at this back number in order to find our factors. Now that there is a number, a coefficient, in the front of our trinomial, we have to include that as we are finding our factors. So we're going to start the process by taking our leading coefficient, 7, and multiplying it by our back term, which is 4. So instead of trying to find just the factors of 4, we're trying to find the factors of 28. That's going to give us 1 and 28, 2 and 14, and 4 and 7. We're now trying to figure out what's going to add to that middle factor. In this case, it is going to be 1 plus 28. So I'm going to go ahead and jump to that box again now. Our leading term, so that's 7x plus, or our 7x squared, is still going to go in that first position. And then our 4, the last term, is still going to go in that back box. Into the middle two boxes, so these leftovers, I have a 1x and I have a 28x. We, again, could flip-flop between those. Then we are looking for our GCF from these first two. So the biggest number that's going to divide them is 1. And then the common factor then is x. To get from x to 7x squared, I need a 7 and another x. To get from x to 1x, I need to multiply by 1. Then I'm going to take and move that across and say what times 7x is 28x and what times 1 is 4. And that is going to give me an answer of 4. So my factored format here is going to be 7x plus 1 times x plus 4. Go ahead and try this one on your own. So we start by multiplying 2 times 10, which is going to give you 20. So our factors are 1 and 20, 2 and 10, 4 and 5. To get to a negative q, which is a negative 1q, I'm going to take 4 minus 5. Again, remember from our tips, if I've got a negative back term, I need one positive and one negative. Then I find my GCF and fill in my remaining factors to get 2q minus 5 and q plus 2. Once again, just like with the last video, you could list those in either order, q plus 2 times 2q minus 5. Next thing we want to look at is, in this case, I've got 10d to the second minus 35d plus 30. We could start right away by doing 10 times 30. That's going to give us 300. One thing we always want to check when we are working with coefficients in the front is to see if this problem can be reduced. So in this case, our first step is going to be to divide everything by 5. That 5 will be included in our final answer, but it allows us to work with smaller numbers. So 2d to the second minus 7d plus 6. Now I'm going to go through and do my multiplication of 2 times 6, which is going to give me 12. So my factors are 1 and 12, 2 and 6, 3 and 4. And I'm looking for something that's going to get me to negative 7, which in this case is going to be a negative 3 and a negative 4. So when I go ahead then and plug into my box, my leading term, so my 2d squared, goes into the first part, and my positive 6 goes into the back. Then I'm going to take my two factors, and I'm going to have negative 3d here and negative 4d in this box. Looking for my greatest common factor then, of the first pair, I've got d. Then I've got to get from d to 2d squared, so I need 2 and d. Then from d to negative 3d, I need a negative 3. And moving across negative 2d to negative 4, or negative 3 to positive 6, is going to give me a factor of negative 2. Now, because we divided by 5 at the beginning, the first part of my answer is going to be a factor of 5, and then the 2d minus 3, and then the d minus 2. Again, you could have put d minus 2 in front of 2d minus 3, but that leading factor is going to be the number that you factored out. So again, if we're working with trinomials where there is a leading coefficient, always check to see if you can divide first. Go ahead and try this one on your own. In this case, we can divide by a factor of 2. So then I'm finding multiples to give me 12. I'm trying to get that to equal 11p. So I've got a negative 1 and a positive 12, giving me my final answer of 2 times 3p minus 1 times p plus 4. Sometimes we're going to be dealing again with our different variables. So again, I want to check to see if I can divide 4, 17, and 15 cannot be divided by the same value. So I'm going to jump into my multiplication step, and I'm going to do 4 times 15, which is going to give me 60. So I've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and then 6 and 10. So once I start drawing my box, I've got my first term of 4x squared is going to go in the upper left box, and my negative 15y squared going in my lower right box. Now, when I am looking for my factors here, I want to get to a negative 17xy. There are two options here. I could do 3 minus 20, or I could do negative 5 minus 12. This is where that tip from the last video is going to be important. We have a negative last term, which means that I need one positive and one negative in my two middle terms. So I'm going to use the 3 minus 20 because I have one positive and one negative, as opposed to this bottom option, negative 5 minus 12, which would both be negative factors. So I'm going to put 3xy and negative 20xy into my box. Looking at my GCF for these first two, the only thing they have in common is an x. So to get from x to 4x squared, I've got 4x. To get from x to 3xy, I need a 3 and a y. To get from 4x to negative 20xy, or 3 to negative 15y squared, I'm going to need a negative 5y. So my factors then become 4x plus 3y being multiplied by x minus 5y. Again, you could flip-flop the order you write that answer in. Go ahead and try this one on your own. Nothing can be divided, so we do 2 times 35, giving us that multiplication to 70. We plug in our two factors of 4 and 14, and we solve to get x plus 7y times 2x plus 5y. In this next example, again, the first thing we want to check out is if we can divide. So in this case, I can divide everything by 7. So when I do that, I'm going to end up with a polynomial that says 2a squared plus 5a minus 8. I'm going to go ahead then and multiply 2 times 8, giving me 16. Factors of 16 are 1 and 16, 2 and 8, and 4 and 4. When I look at this list, there is nothing that can get me to 5a. So normally we would call this prime. However, because we could do this division at the beginning, because there was something we could do, we could take a 7 out, which means we can factor 7, and then the rest of your answer is just 2a squared plus 5a minus 8. So because there was a factor of 7 that could be taken out of each term, It is partially factorable, meaning it is not prime. So taking that 7 out and writing our remaining trinomial is an example of factoring this problem. With this last one here, I cannot divide by anything, and I do 4 times 7 to give me 28. So my factors of 1 and 28, 2 and 14, 4 and 7. Now there is truly nothing that can get me to a -1. So because I could not divide by anything, and there is nothing that adds or subtracts to our middle term, this is an example of a prime trinomial that cannot be factored with a leading coefficient. If you have any questions about this or anything else from the lesson, please feel free to reach out and let me know.